Good evening. Today will be the first class of waves. Waves, of course, is physics last chapter, and it is one of the most important chapter ever. So first thing we'll study in waves are the types of waves. Okay. I'll tell you what happens in this chapter. First, we are going to do the basic parts of a waves and the basic definitions in a wave, and some of a little bit of the progressive wave will also be done in this lecture. Now let's get straight into it. This is, of course, important. Now, important formulae, and this is common for all waves. So the first thing is lambda. Lambda you should be known, which is wavelength. Then after that we have the frequency, which is frequency, and after that we have the speed of whatever it is that you are sending the wave. Now wavelength, of course, frequency is 1 by time period. Wavelength is the entire thing. And the wave speed, however, you should note that it is this thing is called as wave speed. And this is the formula number 1. And the second formula we are going to be having is this is equal to 1 by then after that you have to remember this is 3.3 second. After that, this is the wave number, which is 1 by lambda. After wave number we have angular frequency. Angular frequency omega is equal to 2 pi by t. Then we have another thing, k, which is very similar, and this k is equal to 2 pi by lambda. Now if you can see, lambda by t is equal to v, so that's what basically we're going to do. V is equal to lambda by t, so and v is equal to omega by k. This is number 2 of the Mendel formula. You should remember all of these formulas. Then after that we have let's see. We have the relation between one or two parts. One of them is this thing and the other is this thing. So the first thing we will be having is the velocity, types of velocity. Now what they can ask in this here is there is 2 types of velocity. One is the velocity which the wave is moving from. However, we know that a wave is a system of particles. So what happens here is there is a lot of particles in between, right? So these particles will move in this way. For example, in transversal, longitudinal does not have this same formula. So in transversal we see that the molecules will move up and down, here also up and down. Therefore, this one individual particle will have a motion upward or down. Okay? This is incorrect, whatever I have written here. I'll show you how it is done. So how do you find out the normality? Now, okay, coming back. The second thing we have is particle velocity and the normal velocity of the wave. We are going to find out the relation. Now the derivation is really very hard, but what you really need to remember is this is the wave velocity and this, of course, being the particle velocity. Now the relation is, there is only one relation you should be remembering. by v times dx by dt. This is the only thing you should be remembering. And another type of formula which you get by squaring both the sides is d square x by d square t is equal to v square into d square x by d square y, dx square, dx square and dx square and d square y. Now this is the second type of thing formula we have. After these both are finished, then we have one more concept which we need to remember. There is something called as the phase difference, path difference and the time difference. Now there is only one relation between all of them, and there is one relation between all of these three things. One is delta displacement, another is delta time, and the other is delta phase. Now there is and all these are related. Delta lambda by lambda is equal to delta t by total time period, and delta phi divided by 2 pi. This is an angle, this is an angle, this is a time, this is time. This is basically changing this thing, wavelength, and this is the wavelength of the entire wave. This is the third important equation. After this we have one more important equation, which is k is equal to 2 pi by lambda. That if you just switch it a little, you will get phase difference. Now this phase difference is equal to lambda by 2 pi. And this is all for this. You should be remembering this is having a 2 in the denominator. This will get a little bit confusing, but if you remember this, then you are holding. Next we have progressive waves. So progressive waves are basically waves that travel. Unlike stationary waves, like if you take a small piece of thread and if you for example, if you just do like this, it will move. That is basically a progressive wave. Now progressive wave have very take it from the start. Progressive wave have many different formulas. I'm just going to list all of them, and you will find the relation between them very easy. First thing is first thing we'll have is I progressive wave. Y is equal to A sin omega over t minus x by v. Now if you see, x by v is basically time. V here is the velocity of the particle, and x is the displacement. So for example, you have something like this being the displacement, and the velocity the wave travels by. This is basically the time period from here to here. Okay. This is the major formula for almost every single thing over here. Then you have y is equal to a sin omega t minus omega by v times x. Now this is equal to k, so we have a sin omega t minus kx. Now this sign is important. So if this sign is positive, or basically if the sign is same for coefficient of t and x, velocity is equal to negative direction. That is this side. Now if it is different, that means that is moving in positive direction. Then that's it. You can further expand this k and omega to find various other these things, relations. But that's all we have for progressive waves. These are the key formulas I should remember. Next we have the velocity of mechanical wave. This is just a direct formula which you should remember. V is equal to root under T by nu here is equal to mass per unit length. Okay. Let's name this file. Right. Of course, we go to the intensity of wave. Intensity of a wave is intensity. The name itself suggests it is area. Energy per area per unit time, and this is now if you put all the values of energy and if you put the value of area and time, you get the value 2 pi square a square n square rho v. V here is volume. Okay, this is the formula for intensity, and it's a very distribution. After this, you have, of course, there is energy density. Energy density is basically U equal to intensity per unit volume. That's it. Then this volume here will get cancelled out, so it will 2 pi square a square n square rho. And that's all the formulas for progressive wave also. Moving on. Let's finish sound waves and its characteristics. Basically sound waves, ultrasound, infrared and all of those things, you don't really require them. They really isn't. Okay man, I'll just write it in brief. Infra is less than 20 hertz. Then ultra is greater than 2000 hertz. 1000 hertz, and the audible range is between these both values. Then after that, there are some applications which you already will be knowing. Then after that, we have differential waveform and pressure waveform. This pressure waveform is also, they can ask the question. Just remember the formula: delta P is equal to P naught cos omega t minus kx. Just instead of A and here Y, we are having P naught and change in pressure. This is there for the longitudinal wave. Okay. Compression and reflection will be observed over here. Next we have some formulas for sound. Now sound is a really huge this questions. A lot of questions comes from this part. So you should be remembering the relation and you should be remembering the formula very properly. And sound formula. First thing we have is Newton's formula. Now Newton's formula, you have V is equal to root under elasticity by density. Okay, this elasticity by density, this can be gamma for solids and beta or bulk modulus. Gamma is the Young's modulus and or beta, which is the bulk modulus for liquids. This can be the. Then after that we have the speed of sound in air. Now speed of sound in air, if you put these values and all, you will get the value of velocity as directly is equal to. So what Newton did was he got the value as V is equal to root and p by 12. However, it was wrong and it had to be corrected by introducing j gamma here. This, however, this is y. This over here is of course equal, for air it is equal to 1.41. Now if you put this value and you put the value of pressure and density, you will get the required equation. Another form of this is V is equal to root and you can say this is times V. If you do both the sides, you get PV by M. PV by M means basically RT by M times gamma. This is another form of the equation for velocity in air, velocity of sound in air. Okay. Then we have some effects of temperature, then we have some effects of humidity, effects of pressure, effects of motion of air, and effects of frequency. For our first one, effect of temperature, you should remember V is equal to V naught plus T, small t, by 546. Okay. This you can remember it as 273 times 2, because what happens in the formula is you get the formula as V naught into 1 plus this value t by 273 whole to the power of 1 by 2. Now if you open that, you get this inside and you get V naught times V naught plus V naught. Okay. Okay, fine. This is only more important. Just remember this. This is the second equation. First one.